put up the rotor head, we need to have step 5 bag with the washout, the washout arms with their radius arms and the washout block in there. So we'll get that out now and have our rotor head handy. First off, go over the washout block, check they're all tight. I basically found that they're all tight and satisfactorily Loctited in, except one of the little M2.5 bolts into the radius arm there, so I took that out, put a couple of threads of Loctite on there, but the rest are pretty sound. This is a nice design, nice implementation, ball bearings in the radius blocks there. There's very little slop on that, a little bit of flex maybe on the washout arms there, but that's a nice unit. Likewise on the swash, go around with your driver, just check, these look like they're M2 socket header bolts, just go around and check that they're all tight. I don't think you need to fully unscrew them, but a good tweak undone on all the balls will tell you whether or not they're adequately Loctited in. No bling on the swash, but it looks very capable. It's very smooth in rotation. There's no slop in the ball. There's no adjustment for wear, mind, like you get on a few, notably the quick UKs, but that's a pretty nice bit of engineering. I like that. Alright, swash down over the head, and then you can snick up the elevator A-frame ball joint. Get that on there straight away, and that's a pretty nice system there. It's a very rugged frame, this. I like this spacer between the actual alloy and the ball link. Time will tell if there's any length discrepancies between the servo lengths, the ball link lengths from the servos, which we had in the TX700, which caused some concern. This is an interesting variation from the usual. The washout block goes on, and the radius arms can snick onto the inner rings of the ball link. Bit tight, might get the pliers onto that one. Anyway, instead of the phasing pins coming out of the rotor head, which is the norm, and just going down into slots in the rotor head, the phasing pins are actually in the washout block there. And then we have a little block which we can bring down here, a little washout block, and that engages the phasing pins, but this is separate from the rotor head, which isn't physically connected with that at all. And what this basically means is that you've got a means of adjusting the phasing on the heli. Now there's a section later on where we set that up and line it up to get it correct, but if you wanted to tweak it a few degrees either way, all you'd have to do would be to unscrew these set screws here and rotate it around a few degrees. This is for sort of fine precision tuning if you want to get tracking problems out. You're starting to roll during your loop. And the thing is about phasing is that it is affected by different conditions, like if the motor's too lean, different rotor blades, all sorts of variations. So for the perfectionist, I guess trying to do the tight 3D, this is going to be a valuable means of tweaking. Anyway, for now, we'll just assemble that and snick the radius arms on the balls, and we won't set the phasing now until the head's fully assembled. And that's a very free moving washout block assembly, also like that. No dramas getting the Loctite on, just find the hole, line it up, and then with your looks like 20mm M3 collared sleeve, pop that through the nylock on the end, then take out these two pinch bolts here, M3 pinch bolts, clean them up, degrease them, and put them back with some Loctite so there's a nice firm anti-rock joined to the main shaft. Now your rotor head's handy and easy to get at. Go over all the steel screws in the head, front and back. Make sure that they're not going to come undone easily. These are nice and firm, Loctited up. We're giving a warning that the spindle bolts aren't thread locked. We have an 8mm head axle. We've got a Delrin spacer in there. We've got a little spacer washer that goes after there. The inner radial bearing is a 688ZZ, which is 8mm internal diameter, 16 by 5. Now the rest of the stuff is in the grip here. Now I'm not sure how well we'll be able to see that, but the puzzling thing is that we seem to have a radial bearing on the outside there, whereas the exploded diagram of the parts head in the usual practice would be to have a thrust washer there, and it makes most sense to have the thrust washer on the outside. So anyway, let's disassemble the contents of this grip, and there we are, that's the block of bearings that would come out if the screw was out the road. And sure enough, we've got our radial bearing on the outside just underneath the M5 washer, and we've got our thrust washer. At least the thrust washer is, and we've got a spacer as well, which is usual practice between the radial bearing and the thrust washer. And the thrust washer has got the narrow ID on the outside as per usual, and it's well lubricated. It's a ball race, out of thrust race, washer and M5 bolt. That's how I'm going to stick it back together and see how that feels. While we're at it, we'll degrease the spindle bolt and also flush out the axle to get rid of the oil in there with some contact cleaner without lubricant. Alternatively, you can pop a cotton tip down there and clean it out. And that's our head all screwed back together again. These are nice and smooth and free running, and there's no slop whatsoever in there, and it feels pretty solid. There's a little bit of movement in those dampers, but not bad at all. Okay, we'll fix up the flybar now. Now these these seesaw components, the flybar adapter, the seesaw and the seesaw control arm are basically all held together by the flybar kept in place. And to stop all the bits from falling out, Compass have kindly stuck a length of bamboo, the whole length of these tubes, which would basically keep them all together and stop them from falling out. But what we have to do is to introduce the flybar from one end, and having loosened up the 3 grub screws on each side, 1, 2, 3, we should then be able to push out the bamboo and insert. Once you've got the grub screws all loosened up, you can push down your flybar, pull out your bit of best laid plans of mice and men. This set screw not quite undone enough. There we are, and down she goes. And there's our bit of genuine china that's been removed. A little bit of bamboo shoot, strictly against quarantine, of course. Okay, that's our flybar through there, and we'll gently do up these nuts, set screws on the end. Actually, there might be a good idea now to actually position your flybar to get it perfectly balanced up. Once you've got your flybar balanced to your satisfaction, you can then take the set screws out, 2mm on the end and the opposite the crank, and 2.5mm opposite the radius arm, and Loctite those up. The flybar incidentally is 4mm and 55cm long. We can install some ball links now. The ones that are joined together already, 26mm between the bottom of the balls, go between the main grips and the outside ball on the mixer arm. And these are the same size as ready-made Raptor links that you can buy, and you'll be pleased to know that the ball sizes are also suitable for both Quick UK and MA ball links if you want to do any sort of experimenting in the future. These ball links are all pretty tight, and I had to use a ball sizer to try and sort of loosen up most of them. And even so, the head now is pretty stiff, so I'm going to have to keep a close eye on that. Alright, as we progress on, next ball link that we put on is the link between the flybar control arm and the long arm on the washout block down there. Now they say in the manual that it's 46 millimeters between the bottoms of the ball links. In fact, it's longer than that, it's 52. Going on from there, the longest ball link is between the inner arm of the mixer and your remaining inner ball link on the swash, and that seems to be 70 millimeters. The two remaining shortest links of them all, which are around about the 42 millimeter marks, go between the bell crank lever and the swash plate, and they're the same length, obviously, as the link that goes from the ball plate, the ball link there down on the A-frame lever. It's helpful to get a preliminary setup of the phasing ring now. We'll do some final adjustments, more precise adjustments in setup. I'm just going to start off with it about 5 millimeters below the bottom of the rotor head collar down there. Loosen up the grub screws, and then there's lots of different ways you can set the phasing, but a quick and dirty way is to set the fly bar in parallel with the boom, and then loosen off the grub screws and move the phasing ring around until the inner ring ball joints on the radius arms are square with the head, i.e. they're looking straight at you. They should be lined up in the middle, basically, of the shaft. And if you do that, that's going to be about right. But we can go back and adjust the up and down movement when we've found out the swash movement, and also we can tweak the exact angle a little bit later on. So that's the ball links now. The remaining ones are for the servos, the throttle, aileron ×2 and elevator servos. We'll cover that when we come to servo installation, which will be next.